properties of minerals. The chemical properties of minerals show the presence and arrangements of atoms in minerals. Some atoms are bound in the mineral structure. Minerals are thus grouped based on their common chemical content and their crystalline structure. So why do atoms bond together to form minerals? Mineral forms as a result of chemical reaction. Chemical reactions are driven mainly by the arrangement and rearrangement of electrons in atoms. In a mineral, the atoms are held together by chemical bonds which derive from the electrons. We have the first class, the silicate class. Silicate class is the largest group containing silicon or oxygen with some aluminum, magnesium, iron, and calcium. Silicate class is divided into mafic with magnesium and filsec with feldspar. In addition to this, the silicates, owing to their abundance on Earth, constitute the most important mineral class. Even our crust and mantle are all made by silicate. Approximately 25% of all known minerals and 40% of the most common ones are silicate. The igneous rocks that make up more than 90% of Earth's crust are composed of virtually all silicates. Next, we have the carbonate class. The carbonate class is the most found deposit in marine environments. They have been formed from the shells of dead plankton and other marine organisms. As you can see in our image, we have the carbonate classification, the limestone and the dolostone. Dolomite is also a carbonate class. Carbonate sedimentary rocks form through the chemical or biochemical combination of calcium and magnesium with the carbonate anions and are subdivided on the basis of mineral composition. In addition, what is the importance of carbonates? Carbonate minerals are important economic resources. Limestones are excellent reservoir and valuable building stones. Unconsolidated sediments may be used as a viable source of calcium carbonate for soil conditioning. So how are carbonates formed? In nature, carbon atoms join with oxygen to form the carbonate ion. These ions combine with metal cations to form carbonate minerals. These minerals are commonly formed in sedimentary and oxidizing environment. We have the sulfate class. Sulfate class are found in areas with high evaporation rate and where salty waters slowly evaporate. In addition, the sulfates are an important mineral class and includes some very interesting and attractive specimens. Although many minerals belong to this class, only barite, gypsum, and anhydrite can be considered common. Some sulfate class minerals are soluble and several are fluorescent. So we have the halide class. Halide class contains natural salts and includes fluorite, halite, sulfite, and ammonia components. So halide class is commercially significant halide minerals. Natural cryolite was historically required for the production of aluminum. However, currently most cryolite used is produced synthetically. Many of the halide minerals occur in marine evaporate deposits. Oxide class. Oxide class is perhaps the most important class, at least in human civilization, as this contains the metals considered to be valuable. The most important basic oxide are magnesium oxide, a good thermal conductor and electrical insulator that is used in fabric and thermal insulation, and calcium oxide, also called quicklime or lime, used extensively in the steel industry and in water purification. We have also the sulfide class. Sulfide class are minerals that have important metals such as copper, lead, and silver, which are considered economically significant in the modern civilization of man. So some sulfide minerals are economically important as metal ores. The sulfide class also includes the selenides and tellurides, and arsenides and antimonides, the bismuthides, the sulfanidides, and the sulfosalts. Sulfide minerals are inorganic compounds. We have also the phosphate class. The phosphate class contains minerals with phosphorus, antimony, arsenic, or vanadium. The phosphate class is considered an important biological mineral found in the teeth and bones of many animals. We have also the element class. The element class contains pure native elements. Unlike other mineral rocks that are composed of combination of chemical elements, this class minerals, which are usually metals in naturally pure form but semi-metals. Examples, we have the gold, copper, and bismuth. Rocks are naturally substance consist of aggregate minerals clumped together with other earth materials glued by natural processes on Earth. Rocks, like other materials on Earth, are recycled. The cycle is never ending and it describes a dynamic transition through geologic time. In our figure, the rocks is constantly changed in a cyclic pattern depending on environment conditions. So we start from metamorphic rocks. So in metamorphic rocks, the rocks are melted in magma, and magma cools, then becomes igneous rock. After that, weathering and erosion are the process that involves in process of rocks to become sediments. So those sediments will go to the ocean floor, and as time passes by, millions of years, compaction and cementation will help the sediments to become sedimentary rocks. So we have this figure. The oldest rocks on Earth are 3.8 billion years old, while other rocks are only a few million years old. This means that the rocks have been recycled. The process that does this is called the rock cycle. In the rock cycles, time, pressure, and the Earth's heat interact and create the different type of rocks. There are three categories of rocks: the metamorphic, igneous, and sedimentary. So we have the image of the oldest rock. The oldest rocks on the planet, which date back over 4 billion years, are felsic rocks that are rich in silicon and found in Canada's Acasta River. A new study has found that these rocks must have formed at extremely high temperatures and at a surprisingly shallow dip in the Earth's crust. These zircon crystals found in Australia has been dated to just 100 million years after Earth's transformation, indicating that the planet's crust had solidified early on with the temperatures cool enough to allow the formation of early oceans. So we have the image. A slice of Carboniferous chondrite. The round dots are chondrules. They were formed from the original dust of the solar nebula that evolved into the planets. Early on, the dust was flash heated and congealed into tiny spheres. The white minerals called a calcium aluminum inclusion is slightly older than the chondrules. Our planet was originally a ball of molten rock, as you can see in our image, bombarded by meteorites and heated by gravitational contraction. Heavier materials like iron and nickel sank to form a core, which is eventually our inner core and outer core, while lighter silicates floated on top as a global magma ocean. Those are the mantle and the crust made of silicate materials. Welcome to Earth during the Hadean era, named for Hades in the hellish hot condition at that time. Yet, just 100 million years later, the zircon discovery indicates Earth had cooled enough for a solid surface to form and water to begin accumulate into the early oceans. Rocks are very useful for us. In this image shows that rocks can be made in different kinds of product. A kitchen made of granite, hollow blocks, and granite table, all made of rock materials. So let us discuss the three types of rocks. Rocks keep changing from one type to another in the rock cycle. There are three major types of rock that are formed: the igneous, sedimentary, and metamorphic rocks. As such, sedimentary rocks can change into metamorphic or igneous rocks. Hence, these the three types of rocks are. So, the first one is igneous rocks, a word derived from the Latin word ignis, which means fire, are formed from cooling and solidification, known as crystallization, of molten or partially molten volcanic materials that came from within Earth's like magma. In our figure are examples of igneous rocks: the granite, the scoria, the pumice, and the obsidian. So the granite rocks form when slow cooling of pockets of magma take place deep below the Earth's surface. Scoria rock or basalt rock forms due to a quick cooling of the lava during underwater volcanic eruption in the sea or the ocean. Pumice or pumice rock forms when a lava cools quickly above the ground. These rocks have sponge-like appearance, as you can see in our image. Obsidian rocks forms due to rapid cooling of molten lava above the ground. They look like black glass. So igneous rocks are also very important because their mineral and chemical makeup can be used to learn about the composition, temperature, and pressure that exists within the Earth's mantle. They can also tell us as much about the tectonic environment, given that they are closely linked to the convention or convection of tectonic plates. For economic use, many of the igneous rocks are used as building stones, facing stones, and decorative material, such as that used for tabletops, cutting boards, and carved figures. Pumice is used as an abrasive material in hand soaps, emery boards, etc. Next, we have the sedimentary rocks. Sedimentary rocks is from the word sediment, which means to settle at the bottom. Are rocks that have formed from different material deposits on Earth's surface. So we have the figure of different types of sedimentary rocks. The first one is sandstone. It's used for construction of buildings, statues, and temples. We have also the conglomerate. It is found uses as ornamental stones. We have the limestones is used for manufacture of writing chalk, concrete, and glass. Gypsum is used in the form of plaster of Paris, casts and molds. Shale rock is used for manufacturing bricks, tiles, and Portland cement. Sedimentary rocks tells us what the Earth's surface was like in the geologic past. They can contain fossils that tell us about the animals and plants or show the climate in an area. Sedimentary rocks are also important because they may contain water for drinking or oil and gas to run our cars and automobile and heat our homes as geothermal energy. Sedimentary rocks are economically important also, in that they can easily be used as construction material because they are soft and easy to cut. Sedimentary rocks often form porous and permeable reservoir in sedimentary basins in which water and important minerals such as oil can be found. We have also the metamorphic rocks. Meta means a change and morph means form. These are rocks that are formed from igneous or sedimentary rocks that were exposed to high pressure, high temperature, or combination of both, deep below the surface of the earth. So limestone can be a marble in terms of metamorphism or metamorphic rocks. Shale can be slate, sandstone, rich in quartz can be quartzite, and granite rocks can be gneiss. Those are the representation of metamorphic rocks. How rocks change from sedimentary to igneous or igneous to sedimentary. So what are the economic importance of metamorphic rocks? Valuable because metamorphic minerals and rocks have economic value. For example, the slate and marble are building materials. Garnets are used as gemstones and abrasives. Talc is used in cosmetics, paints, and lubricants. And asbestos is used for insulation and fireproofing.